Hello everybody, welcome back to the chapter Quadrilaterals. In this period we will move on to few more examples related to parallelogram. In parallelogram ABCD, 2 points P and Q are taken on the diagonal BD such that DP is equal to BQ. These two sides are equal and the whole shape is a large parallelogram. Show that APD is congruent to CQB. To show these two triangles are congruent. For that we have AD is equal to BC because they are the opposite sides of a parallelogram. And we have the Z shape. If you can notice here, the Z shape, these two angles are equal. Angle ADP is equal to angle CBQ, alternate interior angles in the parallelogram. Also, DP is equal to BQ is given. So we have side, angle, side. By SAS, triangle APD is congruent to triangle CQB. And it is clear that AP is equal to CQ by CPCT. AP is equal to CQ. Corresponding parts of congruent triangles are equal. So we have proved the second part. Next, we have to show that AQB and CPD are congruent. For that, again, we have AB is equal to CD. Also, we have a Z shape here. The angle ABQ is equal to angle CDP, alternate interior angles. This is because opposite sides of a parallelogram. And also we have BQ is equal to DP given. So by SAS, triangle AQB is congruent to triangle CPD. And we can see AQ is equal to CP, AQ and CP. So AQ is equal to CP because corresponding parts of congruent triangles are equal. Next, we have to show that APCQ is a parallelogram. For that, we already have AP is equal to CQ from part 1. So AP is equal to CQ and AQ is equal to CP. Since both pairs are equal, that is a parallelogram. AP, CQ. Therefore, APCQ is a parallelogram because both pairs of opposite sides are equal. All right, moving on to the next question. ABCD is a parallelogram and APCQ are perpendicular. So we are given that these two angles are 90 degrees. Now we have to show that APB and CQD are congruent. For that, we know these two are equal because it's a parallel. These are the sides of a parallelogram. DC is equal to AB, opposite sides of a parallelogram. Angle P is equal to angle Q 90 degrees. It's given. Also, we have a Z shape here, if you can notice. So the angle at the top and bottom are same. So angle CDP is equal to angle ABP. Alternate interior angles. Again, this is because it is a parallelogram. So by AAS, angle side, by AAS, triangle APB is congruent to triangle CQD. And by CPCT, we can show that AP is equal to CQ. Corresponding parts of congruent triangles are equal. That was an easy question. In triangle ABC and DEF, AB is equal to DE and AB is parallel to DE. AB is equal to DE and AB is parallel to DE. This is given to us. Therefore, AB ED is a parallelogram. Can you say the reason? Very good. One pair of opposite sides are equal and parallel. So that was the first part. Next, we have to show that BEFC is a parallelogram. Again, we are given that BC and EF are equal and parallel. So BC is equal to EF and BC is parallel to EF. Again, by the same condition, we can show that BEFC is a parallelogram. The same reason. That was the second part. Next, we have to show that AD and CF are parallel. For that, we have to apply the parallelogram ABED. Since ABED is a parallelogram, we can see that AD is parallel to BE because they are opposite sides. AD is parallel to BE and AD is equal to BE because they are the opposite sides of a parallelogram. And from BEFC, we get CF is parallel to BE. CF is parallel to BE and CF is equal to BE. Also because they are the opposite sides of parallelogram. So from here, we can find AD with BE, they are equal. Again, BE is equal to CF. So BE is common. So finally, we can say that AD is the same as CF in measurement and they are parallel. Therefore, AD is parallel to CF and AD is equal to CF. That was to be proved in the third part. ACFD is a parallelogram. So we have proved AD is parallel to CF and AD is equal to CF. Proved above. From these two conditions, we know that ACFD is a parallelogram. One pair of opposite sides are equal and parallel. So that one is cleared. Now AC is equal to DF. AC and DF are the opposite sides of parallelogram, so they are equal. AC is equal to DF because it is the opposite sides of a parallelogram. And the last part we have to show is ABC and DEF are congruent. We are already given AB is equal to DE. Also, we are given that BC is equal to EF. So we get all the sides side, side, side by SSS congruence. Triangle ABC is congruent to triangle DEF. Hope it's clear. Moving on to the last question of this exercise. ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC. Such a trapezium has a special name, if you remember. Excellent. That is called an isosceles trapezium. Two sides are equal. Now we have to show that angle A is equal to angle B. To show they are equal, they are also given a hint to construct CE parallel to AD and to join on the line which is extended by AB. So finally we get that AE is parallel to DC. AE is parallel to DC. By construction, AD is parallel to CE by construction. So both the pairs are parallel. So we find that ADCE is a parallelogram. So we get AD is equal to CE, opposite sides of a parallelogram. So these two sides are equal. CB is equal to CE and triangle CBE is isosceles now. So we can find the base angles. If this is A, that's also A. Therefore, angle E is equal to angle EBC because it is an isosceles triangle. We know that angle A plus angle E is 180 degree because same side interior angles are supplementary. Also, angle ABE, angle ABC plus angle CBE is 180 degree because linear pair, or it is forming a line. Therefore, angle A plus angle E is equal to, because the right sides are equal, we can say the left sides are equal. Angle ABC plus angle CBE. CBE is angle the same. CBE is angle A. This is also angle A. So these two are same. Finally, we get the answer. Angle A is equal to angle B. Therefore, angle A is equal to angle B. Well, now we have to prove that angle D and angle C are equal. For that, we know that ADCE is a parallelogram. So angle A plus angle D is equal to 180 degree because same side interior angles are supplementary. Okay. Also, here we can see same side interior angle. Angle C plus angle B, angle C plus angle CBA is 180 degree because of the same reason. We have a C shape there. Now we again get the right sides are equal. So we have angle A plus angle D is equal to angle C plus angle CBA. But we have proved that angle CBA and angle A are the same from above. Equal from part 1. So we get angle D is equal to angle C. That was the second part of the proof. And now we have to show that triangle ABC and BAD are congruent. It is an easy part. We have AB is common. We have a side now. Angle A and angle B are equal, we proved in part 1. Angle A is equal to angle B from part 1. And we already have AD is equal to BC, it's given. So by side angle side, triangle ABC is congruent to BAD. That was the third part. And finally, we have to show AC and BD. You got it, right? AC is equal to BD because corresponding parts of congruent triangles are equal or congruent. Wasn't it easy? That's all for this exercise and hope it's clear. Thanks for watching and see you in the next period.